My background is electrical engineering and computer science, and when I started as an undergraduate student I was mainly working on speech processing, and then I decided that image processing was much more interesting for me. So my PhD was on a military project trying to apply image processing for target detection, for example, in a military scene. And then I decided that medical applications are much more interesting for me, and I moved towards biomedical engineering. So right now I can apply my engineering in background and computer science, and more specifically in computer vision, for medical applications and support and help surgical navigation. So what I am doing actually is that I am providing enhanced vision to the surgeon during robot-assisted operation. The beauty of my research area is that it's a very multidisciplinary area. So I have the opportunity to combine computer vision and engineering with on a clinical application. So I work very closely with clinicians, with surgeons. I have the opportunity to go and attend operations in the operating theater, and it's very exciting to see that what you are doing can actually help a little bit society and humans. Today, even with the best surgery, brain cancers kill more children and adults under the age of 40 than any other cancer. And this is because the surgeons do not have yet the right tools to navigate through the delicate pathways of the human brain accurately and safely. The idea is to use computer vision to build the 3D morphological structure of the surgical environment and use this structure to guide robotic scanning. So the robot will go to the surgical scene, it will capture tissue characteristics using imaging modalities like endomicroscopy and intraoperative ultrasound, and then machine learning is used to analyze all these characteristics, all these images, and provide diagnosis support to the surgeon. Scanning large tissue surfaces with these imaging probes is very challenging with a bare hand because of the flexible nature of the probes and their very small field of view. So a human hand would never be accurate enough, but give this probe to a robot and then you can have accurate scanning of the entire surgical scene. The work is mainly program-based. I code a lot to create these 3D models of the surgical environment. Also the robotic guidance and control involves a lot of coding as well. The online diagnosis support is based on machine learning, so we are building deep learning models which are trained to recognize different types of tissue and different characteristics of the tissue. The programming languages I am using involve a bit of everything, a bit of MATLAB, then translation to C++ and Python. So making a career decision back at the time was not that easy. So if I had to send a message to myself a few years ago, I would say that try to explore many different research areas, talk to experts in these areas, try to find something that you are good at, that can combine your good skills and also your interest, work on something that you really enjoy, and always set high targets and goals.